Hello everyone, welcome to Edupedia World. Today we are going to discuss acids, bases and salts. Today's lecture is covered under the following heads. Let's start with Introduction to Acids and Bases. The word acid is derived from the Latin word acidus, meaning sour to taste. In our daily life, we come across many acidic substances such as citrus fruits, tomato, vinegar, tamarind, yogurt, cleansing agents in toilets, medicines such as aspirin, folic acid, vitamin C, boric acid, etc. And there are some other substances also which are known as alkalis and bases, whose properties are different and opposite to that of acids. The word alkali is derived from the Arabic word meaning calcined ashes of plants. These were first isolated from the ashes of plants and hence were given the name alkali. With time, various theories about acids and bases have been developed. Each of these theories has particular advantages. We will discuss here two concepts of acids and bases. The first one is Arrhenius concept of acids and bases, and the second is Bronsted Lowry's Proton concept of acids and bases. Let's start with Arrhenius concept of acids and bases. A Swedish chemist, Svante Arrhenius, defined acids and bases as: acid is a substance which produces hydrogen ions when dissolved in water. Examples of acids are hydrochloric acid, that is HCl, sulfuric acid, that is H2SO4, nitric acid, that is HNO3, carbonic acid, that is H2CO3, phosphoric acid, that is H3PO4, and acetic acid, that is CH3COOH. And according to him, a base is a substance which produces hydroxyl ions when dissolved in water. Example: sodium hydroxide, NaOH, potassium hydroxide, KOH, ammonium hydroxide, NH4OH, calcium hydroxide, CaOH whole twice, and magnesium hydroxide, MgOH whole twice. In aqueous solution, a hydrogen ion always combines with a molecule of water to give hydronium ion. When hydrochloric acid is dissolved in water, it undergoes dissociation. We can write it in the chemical form. Hydrochloric acid, that is HCl, when it is dissolved in water, here HCl is in aqueous form and water is in liquid form, it will give hydronium ion, that is H3O positive, which is aqueous, and chloride ion, which is also aqueous. This sign, it indicates that dissociation is reversible, which means that hydronium ion and chloride ion can recombine to form hydrochloric acid and water. We can also write the dissociation of some acids in aqueous solution. We will write it. Suppose HBr in aqueous form reacts with water, which is liquid. It will dissociate into H3O positive hydronium ion and bromide ion. So it means that hydronium ion and bromide ion can recombine to form HBr and water. Second example, H2SO4. It combines with water and will produce twice hydronium ion, aqueous and sulfate ion, which is also aqueous. Now we will take another example of nitric acid, HNO3 reacts with water. This sign actually means that this reaction is reversible reaction. Aqueous. Now phosphoric acid H3PO4 reacts with thrice H2O liquid, reversible sign, hydronium ion again and phosphate. Now we will discuss some more examples on dissociation of some bases in aqueous solution. We know the examples of bases like NaOH, KOH, NH4OH. Now we will discuss the chemical reaction for dissociation of these bases. NaOH reacts with H2O liquid. It will dissociate into Na positive and OH negative. Both are aqueous. Now KOH aqueous reacts with H2O liquid, K positive and OH negative, aqueous. Now NH4OH reacts with H2O. It will dissociate into NH4 positive and OH negative. Now calcium hydroxide reacts with water. It will give Ca2 plus twice OH minus. Both are aqueous, liquid and aqueous in nature. According to Arrhenius concept, acid-base neutralization involves reaction between H positive and OH negative ions to form a water molecule. It involves a reaction between H positive and OH negative. So what happens? That H positive and OH negative, they react and they will form H2O liquid. We can also write the above equation as H3O positive, that is hydronium ion. It reacts with OH negative, that is hydroxide ion, and will form water. So these are the examples for dissociations of acids and bases. Now, limitations of Arrhenius concept. This concept has some limitations. The first limitation is It recognizes the dissociation of acids and bases and acid-base behavior in aqueous medium only. It cannot explain the acid-base behavior in the absence of water and in non-aqueous medium. The second limitation is it restricts acids to merely hydrogen-containing compounds and bases to merely hydroxide-containing compounds. The substances such as CO2, SO2, SO3, etc. are not regarded as acids, and the substances such as NH3, Na2O, CaO, MgO and Na2CO3 are not regarded as bases, though they exhibit properties of acids and bases. The second theory for acids and base is Bronsted Lowry's proton concept, and according to this, an acid is a species. It may be a molecule, a cation or an anion which is capable of donating one or more protons to any other substance. Such an acid is called Bronsted Lowry acid. And a base is a species. It may be a molecule, a cation or an anion which is capable of accepting one or more protons from an acid. Such a base is called Bronsted Lowry base. In short, we can say that acid is a proton donor and bases are proton acceptors. Let us discuss some examples of Bronsted Lowry acids and bases. First, we will discuss some examples of Bronsted Lowry acids. Bronsted Lowry acids. They are proton donors. First is H2O. It will dissociate into H positive and OH negative. Second is HCl. It will dissociate into H positive and so they are donating proton, as we can all see. Now H2SO4, it will give H positive and HSO4 negative. HNO3 nitric acid, it will give H positive and NO3 negative. NH4 positive ammonium, it will give H positive and NH3. H2CO3, it will give H positive plus HCO3 negative. And HNO2, it will give H positive and NO2 negative. So all Bronsted Lowry acids are proton donors. Now we will discuss examples of Bronsted Lowry bases. Or we can say they are proton acceptors. They are accepting protons. Examples are H2O plus H positive, it will give H3O positive hydronium ion. NH3, it will react with H positive and it will give ammonium ion. NH4 positive. HSO4 negative, it reacts with H positive and it will give H2SO4. OH negative plus H positive, it will give H2O, water. Another example is NO3 minus plus H positive, it will give HNO3, nitric acid. Cn negative, it is accepting proton and it is giving HCN. HCO3 minus, it will react with H positive, it is giving H2CO3. So these are the examples of Bronsted Lowry bases or proton acceptors. Water acts as proton donor and as well as proton acceptor. So it acts as both as an acid and as base. Now consider another reaction. HCl is reacting with NH3 and reversible reaction sign NH4 positive and Cl negative. Here in this reaction, hydrogen chloride gas reacts with ammonia to give ammonium chloride. HCl donates one proton to become Cl negative and NH3 accepts a proton to become NH4 positive. So HCl is acting as, or we can say HCl is a Bronsted Lowry acid. Why it is Bronsted Lowry acid? Because HCl is donating one proton and it is becoming Cl negative, and NH3 is a Bronsted Lowry base. Why it is Bronsted Lowry base? Because it is accepting proton and to become NH4 positive. Now we will discuss some other Bronsted Lowry acid base reactions. H2O reacts with NH3, it will give NH4 positive and OH negative. HCl reacting with H2O, it will become H3O positive and Cl negative. In the first reaction, NH3 accepts a proton to become NH4 positive. So it is Bronsted Lowry base and H2O is Bronsted Lowry acid. Now take another reaction. NH3 plus H2O accepting proton, so it is a base. NH3 is accepting proton, so NH3 is Bronsted Lowry base and H2O is Bronsted Lowry acid. Another reaction, HNO3 reacts with H2O, will become H3O positive and NO3 negative. Here water, that is H2O, is accepting a proton, so water H2O is Bronsted Lowry base and HNO3 is Bronsted Lowry acid. another reaction, H2SO4 reacting with H2O, it will become H3O positive plus HSO4 negative. Again, here water is acting as Bronsted Lowry base and H2SO4 is Bronsted Lowry acid. Take another example. Water is reacting with H2O. It will give H3O positive and OH negative. This reaction indicates that water can act as both Bronsted Lowry acid and Bronsted Lowry base. So water is amphoteric substance. Amphoteric substance. The substances which can act both as an acid and a base are called amphoteric substances. The acid-base neutralization is represented by the chemical equation, as H3O positive acid reacting with HO negative base. It will give H2O and water. So this is the acid-base neutralization in aqueous solution. Now, limitations of Bronsted Lowry's concept. This concept cannot explain the acidic nature of CO2, SO2 and SO3, and also the basic nature of Na2O, CaO, MgO and BaO. Thanks for watching Edupedia World Videos.